Hey everybody, this is Mr. D from the CCIC. Hope you're well and healthy. Here to teach you some math to go into the medical world. You're going to need a few things before we get started. Ideally, a calculator. And if you want to go to your Google Classroom, you'll follow some notes here. You can help follow along, and those same notes are available in your Schoology right here in this funky looking file, health and wellness intro math notes. Go ahead, open those. You can print them off, follow along, and then take some notes and questions along the way. Here we go. So here's what I did. I went ahead and put this first thinking question on here, just to kind of get the brain cooking a little bit. Start thinking about some medical math. So the question asks a client who weighs 60 kilograms is given a drug. That drug is to be administered at 2 milligrams per kilogram of body weight. The stock strength comes in 40 milligrams per 2 liters. And so we're asking the question, what volume of the drug should they be given? We're not going to go ahead and answer this to the very end, but this is a little bit to get you to start thinking about the things you got to know in terms of conversions and whatnot, especially when it comes to administering some drugs. So think about it. All right, here's your learning targets for the day. We're going to hit these 6 bullet points here. First, we're going to start off with some Roman numerals. We're going to talk about height and weight, the differences between the two, averages, some common conversions that you need to know, how to deal with percents, and most importantly, medical time. And then there's some bonus questions for you at the end. Here we go. All right, first things first, Roman numerals. So back in the day, they came up with Roman numerals. We use them now in prescriptions and some stuff in the medical world, but you got to know kind of some of the basic letters before we get going, and those letters are actually numbers. Here we go. This is the letter I to a Roman. That I is the number 1. You've seen this before if you've ever watched the Super Bowl. V is the number 5. X is the number 10. L for 50, C for 100, D for 500, and M for 1,000. Now, these are a little bit weird. There's not a lot of reason behind why they pick these letters, but I will tell you, if you need some tricks for remembering them, which I always do, especially if you're a Spanish speaker, the letter C maybe sounds like CN, and that helps me remember 100, or cent, like there's 100 cents in a dollar. D, I got nothing for you. But the M, you might know that un mil, M-I-L, is 1,000 in Spanish. So just some things for you to think about. Okay, you can write them as capital letters or lowercase letters. Okay, so let's practice some of them. Quick note, the 4s and the 9s get really janky. So if I tell you to write the number 14 in Roman numerals, this is what you don't do. You shouldn't say a 10 and 4 ones. Even though that does add up to 14, you're right. You can't do that because of the rule for 4s. The rule for 4s says that the number 4 we're actually going to consider as 1 before 5. There's not a lot of reason behind it, but just don't put 4 things in a row. 1, 2, 3, 4. You can't do that. You got to say the number 4 is actually 1 before the next bigger number. Okay, so 14 is actually a 10 and 1 before 5. And 10 and 4 make 14. Got it? Okay, so here's a few more examples. 19. Okay, so I got to get as close to 19 as I can. Okay, 19. I'm going to get close to it by making a 10. But then I'm going to say 1 before the next 10. So 10 and 1 before the next 10 is 19. 49. That's 1 before 50. 49. Okay, funky rules for 4s and 9s. You got to practice those. 90. Okay, so we're not going to say 50 and 4 10s. We're going to say 10 before 100. That makes 90. It's kind of like 100 minus 10. Okay. All right. I hope you got all of that. I'm going to have you do this real quick. Hit pause. Okay. And then I want you to fill these out on your note packet that you got off Schoology or Google Classroom. There's 12 of them, and then come back in a second. Okay. Just to try them on your own. Here we go. And I'll get some answers here for you in a sec. All right. Welcome back. Hopefully you tried all of these. Okay. You're challenging yourself. Here's some answers for you. 13, that's 10 and 3 ones. Bam, you nailed it. 29, okay, that's 2 10s, that makes 20, and 1 before the next 10, or just 9, 29. You got it. C makes 100, and L makes 50. 100 plus 50 makes 150. 20, 2 10s, and a 5, 25. You're a genius. X, that's 10 before 100. Okay, never say 4 things in a row. 9s are weird. Okay, this one's super janky. This is 100 before 500 plus 50. You might not like that. Let me go back one. Kind of explain this a little bit. Dang, I gotta write on my screen. Let me get a pen. Look at that. I'm showing you all the answers. Okay, here we go. 100 before 500 makes 400. Look at that. That's your CD. That's 100 before 500. So now we're at 400. And then what do you know? We add 50 to that. That's that L right there. 50. Okay, you might not like that. Get out of this. But that's just the way it is because Romans. All right. Now you might have just been thinking 50 before 500. I guess you could do that too. Okay, 38. Here we go. 10, 20, 30, 35, 36, 37, 38. Okay, 2 ways to think about 99. That's either 1 before 100, but I don't think the Romans like that. So they're going to make you do 10 before 100. That's 90, plus another 9 makes 99. It's weird. Don't ask. CXL, 140. 107. Bam, 100 plus 7 makes 107. You got this. 100 before 1,000, 900. Okay, here's another weird one. 2 ways you could do it. We'll say both of them are right. You good with that? I'm going to turn on this. Just kind of nifty. All right, here we go. Okay, you want to try another little pause? Come back in a few. I got answers for you. Take a note. I've got office hours later this week, so I don't know. Grade yourself and tell me how you did. If you absolutely crush it, then move on. If you don't, then let's do a little bit of extra practice. Okay, here's our next section. Height and weight. Here's something you need to know about the doctor's office. Physicians typically use height bars. They measure in inches, but a lot of prescriptions have to do with non-inches, things like centimeters. All right. Sometimes when you're charting, you got to put it in feet and inches. Other times it's inches alone. All right. Centimeters is the big one because that's what we're going to calculate our dosages off of. All right. The weight, because we're in America, is measured in pounds, but we're going to record that most often in kilograms because that's what we're going to use to figure out our scripts. Okay. So here's the formulas you need to know. Kilograms, big one. There's one number you got to know. It's 2.2. Okay, I'm going to help you find out a way to remember this in a little bit, but how do I go? Do I go up by 2.2, like multiply, or do I divide by 2.2? There's a trick for this. Centimeters, 2.54 centimeters in an inch. Okay, so there's more centimeters and inches, so those numbers typically appear bigger. Like people in Europe, they're like 180 centimeters tall. Okay. All right, so tell me about this number 2.2. Miss Legg has a great way to remember this is she always gives her weight as a European would because it makes you seem smaller than you actually are. What do I mean by that? If I ask for a number in pounds, then you can take to turn that into kilograms, you divide it by 2.2. So say I weigh 180 pounds. Well, that's American pounds. But if I divide it by 2.2, I'm going to seem smaller than I actually am because that's in kilograms. Okay, so if I ask you to turn pounds into kilograms, divide by 2.2. All right, if I give you something in kilograms and I'm asking you to turn it into pounds, you're going to do the opposite. Multiply by 2.2. The number you got to know, 2.2. The thing you got to remember, am I dividing or multiplying? Okay, so here's some practice. Here's just one thing, because you can just whip out a calculator and do this nice and quick. But I want you to pay attention to significant figures, meaning when I'm talking with newborns and I got to round to the nearest tenth of a pound, okay, then we're going to continue to look at. Let me just talk about this. Let's pull up a calculator real quick. 10.3 pounds. Oh, calculator. What did I do? 10.3 pounds divided by 2.2. Okay, 4.68. Look at this. I'm looking at this 8 right here, and this 8, because it's in the hundreds place, tells that 6 that it actually needed to get bumped up to a 7. Okay, so that's significant figures. 5 and above, give it a shove. 4 and below, lie it low. All right, carrying on. How'd you do? All 6 correct? Okay. Big screen. Ow. Ow. Look at that. Okay, this is kind of nifty. So now I'm going to give you a height in just inches alone, but I'm going to ask you to convert those inches into feet and inches combined. All right, there's a few some numbers you got to know. You got to be able to count by 12s. 1 foot, that's 12 inches. 2 feet, that's 24 inches. 3 feet, 36, going up by 12 every time. 4 feet, 48. 5 feet, 60. 6 feet, 72. I don't know too many people that are 7 feet tall, so I stopped there. Okay, so if I ask you to convert 74 inches, here's what I'm looking for. I want you to find the closest thing, foot, that goes into 74 without going over. You guessed it. It's 6 feet. Now, 6 feet only gets me to 72, so what do I got left? Another 2 inches. So I'm going to call that person 6'2". Make sense? 52 inches. Look at my bar across the top here. Ask how close I can get. I can get up to 48. 48 has 4 more left over. That's 4'4". 48 plus another 4 makes 52. 39, 3. 3 gets me to 36. I got another 3 to go. 67 and a half. 5 feet got me to 60 and another 7.5 inches. Okay, you want to try the rest of them on your own? Hit pause, fill it out on your handy dandy note packet, and then come back and check. Okay, 6'5". You know what I did here? Let's write it out. 6'5". I took 6 feet. I multiplied it by 12. And then whatever that answer is, I added 5 to it. See how I do it on the calculator here? 6 times 12, that's 72. I added another 5 to it, that's 77. Okay, 5'9". 5 times 12, that's just 5 feet, but another 9 inches, 69 inches. Okay. I like this pointer. All right. Oh, this is fun. Okay, here's a little test. Why don't you go ahead and pause it and read it to yourself, see how you do. Oh, I didn't have the answer written down. Let's work it out right now. Child weighs 50 pounds. They're prescribed digoxin. That's 8 micrograms per kilogram they weigh per day every 12 hours. How much should be given to the child in a single dose? Here's a few comments to this. What's one dose? A dose is how often they take something. So they should take it every 12 hours. That's 2 doses a day. Okay. Here's your first trick. You guessed it. They told us the kids' weight in pounds, but tricky, the digoxin is prescribed in kilograms. So what am I going to do first? I'm going to take my 50 pounds. Ooh, yeah, 50 pounds. I'm going to divide it by 2.2. Remember, if I'm going from pounds to kilograms, I divide. Here's my first part. 50 divided by 2.2. Okay, so they're 22.7, 22.7 kilogram child. Okay, they're going to take 8 micrograms per every 1 kilogram per day. 8 micrograms for every kilogram they weigh, and they weigh 22.7 kilograms. So let's figure out how many micrograms they're taking a day. That 22.7, they're taking 8 micrograms. 181.6. 181.6 micrograms, mcgs per day. Now, what's the question asking? How much should be given to the child in a single dose? Well, what are they taking? They're taking 2 doses a day. They're taking it every 12 hours. So should I take them 181.6 micrograms at a time? No, I should take 181.6, half of that, 90.8. That's my magic number, 90.8. Make sure you write micrograms, mcgs, because you don't want them overdosing. That's your final answer. Every dose, 90.8. Okay, you like that writing? Great. Here we go. I'm going to skip these. All right, we're in the averages. You guys know what an average is. An average is where you add up all the numbers and you divide by the total quantity of values. So if I have a set of 5 things that I want to average, then I add up all 5 and divide by 5. Okay. To perform an RBC, that's a red blood cell count, 5 areas on the hemocytometer are counted. The counts are given: 101, 99, 105, 98, 102. What do you think? Is that good? What's the average number of erythrocytes per area? I imagine that's just your red blood cell count. Well, first thing I did, I took the 5 numbers, I added them up. That gave me a number, 505. That is not my red blood cell count. Instead, I divide that by 5 because there were 1, 2, 3, 4, 5 values. Final answer, 101 is the red blood cell count. Okay, so the diabetic goes and checks his blood glucose level, QID, back to our Latin, 4 times a day, and obtains the following readings. What's the average reading for the blood glucose? I added them up. I divided by 1, 2, 3, 4, and I got 122. The normal range is between 80 and 120 before eating. Are they still within an acceptable range? Is 122 between 80 and 120? No, it's actually just above the normal range, at least for before eating. And of course, this is patient dependent. Okay, you know how to find an average now. But do you know how to convert from Fahrenheit into Celsius? Let's find out. A few common numbers, things to know about Fahrenheit. 212 is the boiling point. It's a number to know. 32, that's where it freezes. Now this is in Fahrenheit because those same numbers are going to transfer. If you go over to Europe and people are talking about Celsius, they're going to start boiling their water at 100 degrees, not Fahrenheit this time, but Celsius. Okay, so same boiling water, by the way. It's just 2 different numbers, 100 or 212. 0 is where water freezes. How nice is that? 0 to 100. Gosh, nice clean numbers. Okay. Well, if you're taking a European vacation, not during now, of course, a pandemic, you got to know how when it says 30 degrees Celsius on your phone, you don't, throw in all your winter parkas because it's actually really nice over there. You got to know how to convert the 2 numbers. So here's how you convert Celsius into Fahrenheit. If I want Fahrenheit, I'm going to take my degrees Celsius, I'm going to multiply it by 1.8, and I'm going to add 32 to the number. One more time. I'm going to take my degrees Celsius, I'm going to multiply it by 1.8, and I'm going to add 32. If I want my answer in Celsius, then I take my degrees Fahrenheit. First, I subtract 32 from it, and then I multiply it by 0.56. You got those 2 formulas written down? Okay, so let's try it. 37.5. Okay, what did I do? 37.5. The first thing I did, let me go back a slide. I've got an answer in Celsius. So I'm going to multiply it by 1.8 first, add 32. 100.4 degrees Fahrenheit. Say, subtract 32 from it and times by 0.56. There you go. Okay, so here's what it tells me. The liver's been removed from a brain dead donor. During the helicopter flight to deliver the liver, it must be kept just above freezing at 36.5 degrees Fahrenheit. So what must the temperature of the liver be in Celsius? Right? Probably because the cooler has a Celsius reading. Make sure it's not too hot, not too cold. Step 1, 36.5 minus 32. Okay, so subtract that first, hit enter on your calculator, get a new number there. Don't keep going because you'll accidentally screw up your math if you don't use your parentheses right. Then you multiply that number by 0.56. It tells you leave that liver at 2.5 degrees Celsius. Go save lives. Here we go. Second to last portion, we talk about percents. There's a few ways to talk about percents. Like, for example, if I wanted to say 90%, I could say you got a 90 out of 100. Okay, I could reduce it. I could even say you got a 9 out of 10. They're both 90%. I could give it to you as a decimal. You've seen this before in the grade book. I give you a 0.9. Okay, well, that's great because that's still a 90%. I could also just say 90%, but with the percentage symbol. Okay, so there's 3 different kind of percent problems. We call these is and of problems. I put this little kind of handy dandy trick up here. You could put in a box at the top of your notes. We say is over of equals percent over 100. Now, if you don't like to do it that way, that's fine. Sometimes you just like to read it out loud. But if you ever get stuck, put the right numbers in the right boxes. There's 4 different choices to choose from. And one of them is almost always the 100. Okay. So let's go to our green box right here. This is the easy box, right? Because it's green. All right. So let's fill in the things we know. What number is 20% of 400? Okay. Again, you don't have to do it this way, but this is a good way to do it if you get stuck. What number is? So because it says what number is, I do not know my is value. And so I'm going to put an X, like a question mark, in the is box. And then it says of 400. So I'm going to put the 400 in the of box. And then I know the 20 because it told me 20%, and that's out of 100. Okay. So you could do your handy dandy, cross multiplication here if you wanted to, or you could simplify your numbers, or you could just take 20% as a decimal multiplied by 400, and that's 80. Now, if you tested yourself and did 80 out of 400, you should get 20%, 1/5. Okay. Here's the yellow box. This one's a little tougher. Fill in for me. Yeah, I did. Okay. What percent of 82? Look at that. I put 82 in the of box is 20.5. So I know my 20.5 and my 82. Well, if I divide these right now, go in my calculator, 20.5 divided by 82, it's going to give me what that X is, but it's going to give it to me as a decimal. It's going to say 0.25, so I know that's 25%. Boom. Okay, last one. This is the toughie, the red one. 175 is, put 175 in the is box. Of what number? Oh, sorry, is. Oh, don't put 35 in the is box. 35 is obviously percent because it comes with the percent sign. Of what number? That's my X, that's my unknown. Okay, you don't remember back here on the green problem, we multiplied 400 by 0.2. This time we're going to divide our number by the percent. But back here we multiplied to find a percent of something. And this way over here we divide to find it is a percent of what? So 175 out of 500. 175 is 35% of 500. Put these together, 175 over 500, and you're going to get 35%. There you go. Here's a chance to put yourself to the test. Go ahead and try this one on your own. Let me read it for you, and you can pause and try it. During a 1-year period, a hospital admitted 1,526 patients with heart attacks. If this represented 28% of the total patients admitted to the hospital, how many total patients were admitted? So 1,526 is only a portion of the patients. We don't know the total number of patients, but we do know that 1526 was 28% of the total. So what problem is this like back here? We're saying this is the tough one. 175 is 35% of what total? In this case, 1526 is 28% of what total? 1526 divided by 0.28, 5,450 patients. Try this. See if it works. 1,526 divided by 5,450, and you should get a nice happy 28%. Okay, so that's how many total patients there were. This is just the heart attack patients, and 5,450 is the total patients. Next question asks, how many labor and delivery patients were there? If labor and delivery represented 16% of the total, well, now I know my total is 5,450, and I want 16% of that. So 872 patients per L&D. How'd you do? Okay, last section. Here we go. Reading military time. This stuff's fun. It's a 24-hour clock. Now, if I'm in the morning, I just count 1 to noon, or I should say midnight to noon, like I normally would. It's 1 a.m., 2 a.m., 3 a.m., 4 a.m., so on. And then it gets to noon, and normally we would start saying 1 p.m., but in military time, we're not going to say a.m. and p.m. at all. We're just going to start counting up from 12, and as soon as it passes noon, we're going to go to 1300, 1400, 1500. Now you notice me say hundreds. There's because there are some rules for military time. Here's some of these rules. We always use a 4-digit number. We always lead with a 0 if it's before noon. For example, 9:38 is 09:38. Noon is 1200. Midnight's 0000. Okay. Afternoon, just like I said, it keeps counting. 1200, 1300. That's 1 p.m. 1400, 2 p.m. so on. Okay. So it's regular time, 09:38. 09:38. That's because it's before noon, so I just threw a 0 out front. 1:56 p.m. Now, careful, we're afternoon. We're actually 1 hour afternoon, so now I'm to the 1300s. 1356. Because 12 would have been 12 noon. 13, it would have been 1 o'clock. 11:30 p.m. Okay, I'm 11 hours past noon, so I'm at 2330. 2330. Okay, what if I told you 1515? 15 is how many hours past 12? 3 hours. That must be 3:15. How about 0330? Look at this. O. If it's a 0 out front, then it must be early morning. That's 3:30 a.m. You got military time? Try these 6. Here we go. How'd you do? 10:20 p.m. That's 22, 24, 23. That's 4 hours after noon. 16. 12:45 a.m. 0045. 12:45 p.m. 12:45. What did you do? Okay, I'm going to come back to these first thinking problems. If you didn't get a chance to try these earlier, then I just want you to take a second, believe in yourself, pause the video, and come back when you're ready. All right, here's my first thinking problem. I'm going to set up a little table here. I know I have a client that weighs 60 kilograms. I'm going to take a drug, not me, the client, that is prescribed at a strength of 2 milligrams per every kilogram. Okay, so that's how much I need to take. For every 1 kilogram I weigh, I need to take 2 milligrams of the drug. Okay, now it comes in a liquid form, probably diluted in distilled water, maybe. And for every 40 milligrams I take, it's diluted into 2 milliliters of, say, liquid or stock, you name it. Okay, so how many milligrams do I need to take first? Well, I weigh 60 kilograms. I take 2 milligrams for every 1 kilogram I weigh. So I need to take 120 milligrams. For every 40 milligrams, notice these switched. And why did I do that? Because in stoichiometry, I need milligrams on top and milligrams to cancel on bottom. So I flipped them. So I know I'm taking 120 milligrams total. Well, for every 40 milligrams, it's diluted into 2 milliliters of stock. So how many times does, well, I don't want to ask it that way. I take 40 milligrams per every 2 milliliters, and 40 goes into, I don't know, just think of the way I would do it, 120. So 3 times, well, that's 3 times, so that's 3 times 2 milliliters. That's going to be 6 total milliliters. If you just got confused, then multiply everything across the top, 62 and 2, that's 240 divided by 46. Everything on bottom. All right. This one's even tougher. Here we go. Patient weighs 55 pounds. Uh-oh, red light, pounds. Got to go back in my notes. A meperidine hydrochloride is ordered for pain at a dosage of 6 milligrams per kilogram of body weight. Holy cow. 6 milligrams per kilogram body weight. Okay, in one day, 24-hour period. Meperidine is available as an injection. We're going to do 50 milligrams for every month, 1 milliliter. What is the total dosage that should be given to the patient? Well, here's the first thing. They weigh 55 pounds. I'm going to make that number smaller, turn it into kilograms. My patient weighs 25 kilograms. For every kilogram I weigh, I'm going to take 6 milligrams of the meperidine solution. That's 150 milligrams per day because it's 6 milligrams per kilogram. Okay, so I know I'm taking 150 milligrams per day. It's coming in a form of, for every 50 milligrams, you're going to take 1 milliliter of liquid. That tells me I need to take 3 milliliters a day. Enough. Okay, last one. And you're certified. The doc orders nitroglycerin infused at 5 micrograms a minute for a patient. The solution that's available is 5 milligrams of nitroglycerin in 500 milliliters of distilled water. At what rate should you set the drip for the patient in milliliters this bag per hour? I'm not going to give you the answer, but you can come see me at office hours on Thursday to find out. I hope you enjoyed. Let me know if you have any questions. You can find my contact info on the Schoology announcement page. Enjoy. Stay healthy. Stay home.